Okay, so I'll be talking about continuous delivery today, and because we've been working on something new for already a year and a half, some of you will be bored right now because you attended the workshop yesterday and heard most of those things, so this will be congested. This is not what it was supposed to happen. Okay, cool. So this is me. My name is Viktor. I just found out that I have 5 minutes less because the guy before me couldn't finish on time, so I'm going to be speaking faster. I work for Cloudbees. We're a company behind some products, and some of those products, one of those you probably know, that's Jenkins. There are others. I'm Google something something, and I work a lot with Docker, so containers, Kubernetes, I don't know, stuff. Anyways, I have a blog, I have books, I have podcast and a Twitter account, and that's about it. So what I did before I started this, I created a cluster. I'm going to save you from misery looking at me doing that, so I'm going to skip those slides. I just created a cluster, and we're going to start talking about CI/CD, right? I probably assume it's 2019. All of you are applying some form of CI or CD, hopefully. If you're not, you're going to tell me. Anyways, so very quickly, what is continuous integration, what is continuous delivery, what is continuous deployment, right? Assuming that you know already those things, so I will be very brief. Continuous integration means that whenever you push something to a master branch of your repository, you do something automatic, but you're not really good at it, so you have a bunch of hours to spend on manual validations and verifications and tasks later, right? So continuous integration is when you do something automatically, and then you have some army of manual labor people doing something else. It's really, we're moving away from that. Continuous delivery, what that means really is that whenever you push something to the master branch, everything is fully automated and you have a release ready for production, right? You trust the process, you know that it will work, all you have to do is click a button and say, okay, go to production now. And continuous deployment, there's the same thing without that button. Every time you push something to the master branch, it is deployed to production, right? That's the ultimate goal of everybody, to have such a good automation, to be so good at what you're doing that you don't need humans involved at all after you commit something to your repository, right? Those things changed drastically since, I don't know, I think that we started speaking about CI maybe like 20 years ago or something like that. And they changed a lot since then. And today we have certain expectations, certain things that we are expecting from our applications and the system that is handling those applications. One of those is to be cloud native. Cloud native, I don't mean runs in Amazon. What I really mean by cloud native is it is elastic, fault tolerant, scalable, and all those things that you're already doing, probably, right? Unless you're working in a bank and then you have a mainframe and all the bets are off. It needs to be cloud agnostic. I assume that everything you're doing today, doesn't matter whether it's applications, infrastructure testing, that it works anywhere, right? You're making sure that you're not tied to a certain vendor, not because there is anything wrong with Amazon or Azure or Google, but because you don't want to be locked into any certain ecosystem. That's very bad, that's very expensive, that's going to be mainframe happening over again. Everything needs to be scalable, right? I assume that your applications are not running when you're not using. Like, for example, right now you're here, and whichever applications are in your system that you personally are using, they're right now not running. They're shut down. If they are, then you're wasting money for absolutely no good reason. So assume that everything you're doing is scalable, and that means from zero to something, from something to zero. Everything is code. You're not pressing buttons anymore. We moved away from that system long time ago. When I say we, I mean industry. So no more clicking buttons, no more filling some fields and drop-down lists and what's or not, right? Everything is defined as code. Everything is storing it, and so on and so forth. Everything is very fast. I assume that your pipelines, it takes like 10 minutes, 15 minutes for the full process, building, testing, deploying, and all those things to finish. If it takes more than half an hour, you're in trouble. If it takes more than an hour, then you're definitely doing something terribly, terribly wrong. And one of the reasons why that is wrong, because when you push something to Git, you want to start working on a new task. You want to start working on a new feature. You don't want to wait for 3 hours until the process finishes, and then you know whether it worked or it didn't. And it needs to be easy. It needs to be something that can be used by anybody, no matter whether you're a Kubernetes expert or a Terraform master or Java developer or whatever you are, you're supposed to be able to use the system easily. So those were the requirements that we set in front of us that we thought that should be followed, and we set in front of us like a year and a half ago or something like that, when we thought, okay, Jenkins, that's cool, that's great, we all love it, but we need something new, we need something that is more in line with what we expect from 2019 and not like 15 years ago when Jenkins was created. So what we did is that we assumed that everybody will be using Kubernetes, everybody is using Kubernetes today, or everybody is planning to use Kubernetes. If you never even heard about what Kubernetes is, you're in deep trouble, you're in wrong industry. Go and become a doctor or a lawyer, right? This is not for you. We adopted Tekton. Tekton is most likely going to be the standard how to run serverless CI/CD tasks. And this is not Jenkins specific, this is simply how most likely, whatever you do in Kubernetes, if you need some CI/CD, some batch type of processes, it's gonna be Tekton, and it's awesome. We use Prow for GitOps and ChatOps. You know what is GitOps? GitOps means that you only push to Git and you don't do anything else in your life except pushing to Git. Helm and few other things. And we created quick starts. So I'm gonna save you from, okay, actually, this might be important. And we took what we found after speaking with a lot of companies, with a lot of teams and stuff like that, that Kubernetes is really, really hard. It is hard to figure out what you need to use. How are you gonna build your images? How are you gonna deploy your images? Are you gonna use Helm? Are you gonna use Kaniko? Are you gonna use Docker? Which one of them is good? Which one of them is bad? It's very confusing and so on and so forth. So what we thought it would be cool to join, to figure out what works best and to make some kind of a bundle and say, okay, this is the way how you do stuff. This is the way how you build. This is the way how you test. This is how the way how you deploy your applications. Basically how you do the whole life cycle of your application from Git until production. We made it to be CLI first. And this is in line with what we expect today. So what I said before, there is no more UI. I mean, there is UI, but you're not supposed, any of you using Jenkins, if you're used to go to Jenkins and click a button for something to happen, that is going away. And I'm not talking even about Jenkins now, I'm talking about basically how industry works. No more buttons. You're all coders. Doesn't matter whether you're writing tests, whether you're writing code of application, whether you are infrastructure, whatever you are, whatever you're doing in this industry, except maybe if you're a manager, you're writing code. That's a very clear rule, and it's very clear that that's where we are as industry right now. So if you're working in software industry, you're not writing code, you're gonna have a big trouble to find jobs. And pray to God that you stay in whichever company you are, because it will be impossible for you to really switch anytime soon if you expect to be in software and not to write code, whatever the code is. So we made it CLI first experience, meaning that everything is run through CLI or API and so on and so forth. You do things through terminal, you do things through editors, you do things through Git. And it's very opinionated. Unlike some other tools, you cannot choose what you're gonna do. You need to adapt to the process. So I'm gonna skip now. This is actually important. Any of you heard about CNCF? You know what CNCF is? Cloud Native Something Something Foundation. Okay, cool. So actually it's not cool, it's embarrassing. Only a few of you heard. So I'm gonna explain. CNCF is basically the place where everything cool is happening right now. Whenever you're thinking about which tool should I use for monitoring, which tool should I use for deploying, which tools should I use for this or that, whenever you have that question in your head, the first thing you should do is to go to CNCF. It's a foundation, it's what Apache was long time ago. This is not that one. CNCF is a real deal, it's a big deal. So everything happening in industry is there. If it's not there, you don't want it. Basically, that's how easy it is. Now, CD Foundation is what we formed like maybe a year ago, something like that, that tries to bring some kind of order and some kind of standard into CD tools, right? There are quite, if you go to the site cd.foundation, you will see that there are a lot of companies there contributing few products which will increase drastically in upcoming months. But basically, this is what you will be looking for when you're interested in CD. And this is not really backed by any single company. This is foundation where industry basically is going to put its attention. So I'm gonna skip, since I know that most of you don't know those things, so I'm gonna skip making you feel bad for not being Kubernetes ninja and all those things. And I'm going to show you how a process and how I see that the things should be working today. And that process, I will be using Jenkins X today, but basically you can forget completely that it's Jenkins X. I'm going to show you how I believe the process should run, and you can do the same process any other way you want. That's all okay. So let's start with I'm gonna switch to my terminal. I don't like slides much, so I'm gonna start showing you things. Can you read this? Is this big enough? Okay, cool. Cool. So let's say that we start from scratch, right? We have a cluster. That cluster is running Kubernetes, and in that cluster we want to work on our projects, right? So what is the first thing you need to do when you start a new project? You need to create a Git repository, right? You need to create some bogus files like hello world something something, right? You need to define your tests. You need to define maybe Docker file where how you're going to build your container images. You might need to define Helm charts because that's how we deploy in Kubernetes. You might need to define a pipeline file that will schedule and orchestrate what happens when you push something to a Git repository. When do you build? When do you test? When do you deploy, right? And so on and so forth. So to start a new project, you need to do to create a lot of things. And that can take anything from 5 seconds to 5 weeks, depending on whether you know what you're doing, how good you are, and so on and so forth. So I'm going to do the same thing. I'm going to create a quick start project. It's going to be based on Go. Anybody working Go here? Only one. Be happy. Yeah, I don't know. What's okay, cool. So it must be Java and .NET, right? COBOL. Is it COBOL? Consulting for banks, COBOL? It must be COBOL. Somebody who's working for COBOL. Somebody must be working COBOL. Okay. We have kind of like, cool. All shades of gray. Excellent. So I'm going to create a project in this case based on Go because I want to annoy everybody except that guy. I'm going to call it something, JSGo, and I'm going to start working on a new project, right? And the system will create everything I need. Hopefully, if it works, we don't know. Maybe Wi-Fi doesn't work. It's a mystery. We're going to find out. There you go. So it created a directory on my computer saying JSGo, excellent, that's the project you want. It figured out that it's Go, so it created all the files I need. It created the Git repository for me. It created a webhook so that every time I push something to that Git repository, it notifies my cluster and does something, whatever that something is, and so on and so forth. So it created a bunch of files. And I'm going to show you that because if I go now to my Git repository, you will see, you will see, if you check a look at the timestamp on the right, you can see that this was created right now, and it has everything I need. Now, what is everything I need will depend from one case to another, right? If it's Java, you need one set of things. If it's .NET, you need others. If it's COBOL, we don't support it. And so on and so forth. So what you need for a project will depend from case to case, but the point is that you're up and running in a minute or few seconds and what's not, right? So this is my repository. It has things I need. How much time I need? Okay, cool. I'm still good. So for example, everybody's darling Docker file. Here it's created for me, right? It's a simple one because it's Go. If it's Java, it would be slightly bigger. If it's .NET, it would be like this. It all depends from case to case. It has a pipeline that defines how should my project behave when I push something to Git. And that pipeline is very simple. It says, okay, do whatever other people are doing with Go. I can extend it, I can change it, I can modify it, I can make it be special for my project. But in this case, I selected, okay, whatever other people define that should be happening with this programming language, I'm fine with that. So we can continue with that, and so on and so forth. I'm going to skip showing you all the files that are there. I am going to show you instead, just to confirm, you can see this is my cluster. This is my repository. It is already notifying my cluster. that I created a project and it should do something with it. And what that something is, I will show you right away. So you can see that the moment I created a project, and it's still running, you can see it running over there. It started building my application, it created container images, it created Helm charts, it pushed them to one registry to another, it ran maybe some tests, we don't know, and now it promoted to the staging environment. You can see from the output here. So not only that it finished building, testing, and doing whatever it needs to do, it already deployed my first release of the newly created application to an environment. I'm going to show you that environment later. For now, let's take a quick look at the logs. Yeah, it looks okay. So if you're interested in the details, what happened, it's over there. I'm not gonna bother you now with them. What does matter is that I configured my cluster, and you can change that from case to case. I configured it to have 3 environments. One that is called dev. This is where I'm running my tests. This is where I'm building stuff. This is where I'm doing that. This is where I'm developing. When I say developing, I'm developing on my laptop, but this is where all the automated processes are running. I have staging environment. Everybody has staging or integration or pre-production, whatever you want to call it. Since I'm lazy, I set it up to auto-promotion, meaning that whenever I push something to Git, it will be deployed there. I don't want to bother with that. I don't want to spend time making those decisions. But production is manual, meaning that I'm still cautious, and I want to make a decision myself when to promote to production. That will not be automated. It could easily be automated, depends on maturity of the team. But in this case, that's not the case. And if you look at it, I created, what was it, like a few minutes ago, I created a new project, Hello World, but it could be more complex. And you can see that if I list the applications in my cluster, you can see that it is already running. The first release, 001, is already running in my cluster. And I can show you that by, what did I want to do? By sending a request to it. So I'm going to copy the address, and I'm going to send a CURL request. And you can see here, this is the output of my newly created application, the application that I created like, what was it, 10 minutes ago, something like that. So it is already running in production, in staging. I'm going to show you production later, but in reality, for those of you who want to go deep and want to understand what's happening behind the scenes, that's great. You will discover quite a few tools. You will discover Kaniko, you will discover Scaffold, you will discover a bunch of open source tools put together to work towards making Kubernetes processes in Kubernetes make sense. But for most of the people, you're probably not going to have 3 years to figure out, 3 years to learn Kubernetes, half a year to learn Helm, and God knows what else, how much time you need for the rest of the tools. So what we try to really make it easy. And making it easy is to let developers, testers, or whatever you are, focus only on your work. So I'm going to show you how that really looks like. How should the system look from developer's perspective, or a tester, or whatever you are. Sorry, those are my notes. So let's say that I'm a developer, right? What do I do as a developer? Let me see. Is this where I put my application? Yes. So I'm a developer. I'm going to start working on a new feature of the project that I just created 15 minutes ago. So what do you do? And I'm not going to do anything that any of you is not already doing. So I'm not going to introduce new tools. I mean, I am in a background, transparent, invisible. But from your perspective, I'm not going to do anything that you're not doing already today. So what do you do as a developer when, or whatever you are, when you start working on a new feature? You create a new branch, right? So I'm going to create a new branch. I'm going to call it my PR. Nothing really special. And then I'm going to save you from looking at me changing code. So I'm going to run this command just to change my code. Instead of saying something HTTP example, it's going to say HTTP PR, right? I'm simulating now a few hours of coding during which I would be coding on a new feature, doing whatever I need to do. So I'm a developer, remember that. And I'm finished, right? A full day passed, maybe day and a half if it's a big feature. And I'm going to say, now I'm finished, I'm done. My feature is ready. I'm going to edit, commit, and push it to my newly created repository, right? Same thing, things that you are already all doing. And then, what do you do next as developers? After you push to the newly created branch, after you finished with your feature, you create a pull request, right? I'm going to create a pull request. Does not matter how you create pull request as long as you do create it. So I created a pull request over there, and let's open it. Let's see what we got. Okay, so this is my pull request. So far I did not introduce any tool that you don't know. I'm working with Git only. So this is my pull request. This is a new feature. This is the description of my feature, whatever the description is. These are the instructions, just in case I'm new to the team and I'm not really sure what's going on. These are the instructions. Say, okay, man, if you want to create a pull request for this team in this project, these are the rules you need to follow. You need to assign it to somebody. Somebody needs to review, and then somebody needs to approve your pull request, right? Those are all the things that you are already doing today. I'm not telling you anything new, really. What might be new is that I should now start communicating with my team and say, can you please review this PR for me, right? And I'm going to assign it to a guy called Farcic, right? And then that guy was just assigned to the pull request. You can see it here because part of the conversation gets translated automatically into some actions. Otherwise, it would be silly for me to say, can you please review this for me, and then go somewhere else and click a button. That's a tremendous waste of time. Now, you can do many other things, all through Git. Like, I know that this is everybody's favorite. You cannot have nobody will ever approve a pull request without a picture of a kitten. Or you can say, this is a horrible PR. Your code is very, very, very bad. Close it. Right? And you will see that the pull request is closed. Or you can say, after a full night of drinking with you, I think I like you after all. Reopen. Right. Anyway, the point is that you can, by making comments and knowing few shortcuts, you can control everything happening with your pull request. And you can trust that the system behind it will do the right thing, whatever that right thing is. And I can say, for example, LGTM, this looks good to me. This is ready for production, ready for staging or whatever the environment is. And of course, the system is saying you cannot LGTM your own PR because that would be cheating. What's the point if you try to approve your own pull request? So I'm going to skip the rest. I'm going to confirm and merge it to staging, and we're going to see what happens when I merge to staging. When I merged, that was wrong what I said. When I merged to the master branch, right? I just merged my, I forgot one thing, one important thing, most important thing. Every time you create a pull request, that pull request is deployed to a temporary environment. I forgot to mention, there is this message saying, okay, the system got your pull request, it created a temporary environment, it deployed your application there. If you want to review it, please do. And then I can go to that application and say, oh, that looks amazing. That looks exactly what we need. This is the feature we were hoping for. Yes, and I will approve it. I think it's okay. And that's very temporary. What that really means is that soon, since I close this pull request, this environment, this deployment will be shut down. It will be destroyed. So it's very temporary. It exists only for the duration of a pull request. Okay, so as I said before, I merged my pull request to the master branch, and you can see here, so far I'm using Git only. I'm showing you those commands more so that you see what's happening in the background, not because you're supposed to know them. All you need to do really is to operate through Git. So what is happening right now is that it is deploying to staging, and the way how it is deploying to staging is not by really deploying, It is using GitOps principles, meaning everything defined as code. So what my process did is that it just went to the repository that defines my staging environment, or production, or pre-production, whatever it is. It changed that repository and said, okay, Viktor said that the version of the application running in staging should be 002, therefore go and figure out what you need to do something about it. And that something about it is that it will be running in staging. And let's take a look. You remember that I changed the output message to something PR? This is still the old release. You know it's old release because it says there's example, and I changed the code of my application to say PR, right? So I'm going to be patient. I'm not really patient, but I'm gonna do my best to be today for you, especially. Let me see what's going on. Yeah, it's still deploying. Still deploying. No, that's not the command I wanted. I wanted this command. Oh, there you go. If you remember, it was saying something example, and now it says something PR. It was automatically deployed to staging, and the only reason why that happened is because I merged a pull request to the master branch, and I configured my system to deploy new releases whenever I merge to the master branch. Okay, that's cool. So the only thing left for me as from the process perspective, right? I created a branch, I developed new feature, I tested it, I built it, and did everything I need. I created a pull request. I reviewed that pull request. I saw the pull request deployment in action. I did everything I need to do. I merged the pull request to the master. It was deployed to staging. Somebody else can test it there, do whatever, and now we're in a final stage and say, okay, I'm ready to deploy this to production. How do we do this? What do we have in production? I have nothing in production right now because I did not deploy anything to production. But I do have applications running in staging environment. I'm going to show you that. There's this one, release 002, because first release was created when I created a quick start, second when I merged the pull request to the master. So second release of my application, and I'm going to promote it to production. I'm going to say, yes, please, I want to promote application called JaxGo, this specific version of the application, to an environment called production. Environment could be called something else. It could be called Viktor does not know what he's doing. It can be anything you want. So I'm gonna save to production, and what the system is doing now, this is not deploying anything to production, right? Let's make it clear. What this command was doing, and you could create that command yourself, it's easy, it created the pull request. It created a pull request in my repository that defines production. And now this pipeline in the background is running and validating that pull request. It's doing whatever it needs to be done to validate that the pull request to change something in production is valid. It works correctly. And what did I do now? Let me see, I messed up. Okay. Plan B. Let me show you how I'm going to deploy to production, even better. Ta-da-da-da. Okay. This is getting serious and live. What did I mess up? What is the repository that defines my production? Here it's my repository that defines production, right? There it is. And let's say, ignore the command that failed. Let's say that what do I want to have in production? Let me see. I need a second. This is debugging live, staging. This is the Git repository defines my staging environment, right? And you can see my application JaxGo release 02 being defined in my Git repository. What I'm gonna do is that I'm going to say, this is a repository that defines production. And I'm gonna say, okay, from now on, I'm gonna push a change to Git that says that this application, this specific version of the application, should be running in production. I'm just going to change the code in a Git repository, nothing else, nothing more. And now you have time for questions, and because it will take approximately 3 minutes until whatever I defined in Git a moment ago is running in production. I can actually show you that live. JX get activity filter tekton production. Because the moment I push something to Git, to the production repository, the pipeline started running. See, it's doing a bunch of stuff. Now it is building Helm chart in this case, and soon it will be running in production. And all I did was to tell Git, this is the application I want in production. I could add 57 applications there, it would still work, as long as they exist. So, this will take a minute more, and at that time, I'm almost done. Just to show you what is running in production right now, nothing. There you go, actually it finished already. That was faster than I expected. This was empty a moment ago. And now when I output the applications running in production, you can see that my application, the one I created half an hour ago, specific release, is available in production. And it is exposed on this address, .io. And if I send a request to my application, I forgot the quote. There you go. I get something, something, something PR. This is the change I did. This is a simulation of my new feature. I just changed the output of Hello World. I didn't want to make it complicated. So, that's the whole life cycle. All I did was created branches and pushing things to Git. The rest was only to show you how things work in the background. But my only interaction as a developer or whatever I am was with Git and writing code, of course. Nothing else. Okay, that's it. That's all from me. Oh, I'm fast. I have 8 minutes. Thank you very much. I work mostly with open source. So please use open source, but don't use it. Make pull requests. Don't complain to people that open source project doesn't work. When it doesn't work, you make a pull request and you fix it. That's how communities work. It's not only taking, it's giving back something. Read my blog, listen to my podcast, buy my books, buy more of my books. Actually, don't buy my books, but if you work in a company where you can expense things, then buy 10 copies. And we have a lot of we have tremendous amount of time for questions. Do we have questions?
Yes, guys, we have questions. So you have voted for one with 9 likes, and the question is, what tool did you use to create this presentation?
RevealJS. So, RevealJS. This one. Not this one. This one. You cannot see it. Oh, you can. You see? RevealJS. It's a JavaScript framework, and you can write your slides in Markdown, and then it will transform that Markdown into whichever format you want. It's really cool. I love it. I'm not very fond of Keynote and what is the Microsoft thingy? PowerPoint.
Oh, yeah.
I don't like things that you cannot do without a mouse. That's my rule.
Okay, there's another question.
Yes, please.
It has 8 likes, just one less.
Okay.
So does YAML files count as a code?
Yes, yes. Everything that is, okay, so anything that is in a format that can be processed by machine is code. Whether that's Python, YAML, JSON, XML, please don't use XML. Anything that can be processed by a machine is code. What that really means that Excel is not code, PowerPoint is not code, YAML is code, Java is code, COBOL is code, and Go is code. So yes, it is code. But by code, I mean it will be understood by a machine. That's my definition of code. Any more?
I think it was a very good answer. There's a time for another one. Okay, let's put it on the screen. So it's a bit longer one. KAS isn't the solution to all our problem. It is an amazing technology, but there are still they're still in the market. There are many Okay, I just think there's but there are still in the market many mission-critical applications. Okay, serving millions of users without using KAS.
Yes.
What do you think?
So yes, it's true. So Kubernetes or any other technology is not going to solve all your problems. And the world was not created yesterday. And that means that we are not all applications were designed to be 12-factor apps and cloud native and what's not, right? So we all have, every company that exists for more than a couple of years has legacy applications. And moving all of those applications to Kubernetes is madness. Now, I know that some software vendors will tell you, yes, take your JBoss application and put it to Kubernetes. Take your COBOL, put it to Kubernetes. That's nonsense. You will not get real benefits from that. So Kubernetes is not solution for everything, and it will never be, nor any other technology will ever be solution for everything. It is a great solution for the cases where you are, first of all, for new applications that you're designing to be closer to 2019, 12-factor, stateless, scalable, all those things. So it is a great solution for new applications, and it is a great solution for applications that you think are worth refactoring. So if you can refactor your application and make it more in line with the principles of Kubernetes, it's great. But it's not a solution for everything. And also, like what I showed you with Jenkins X, when I said we assume that everybody will be using Kubernetes, what I really meant by that is that everybody who is doing something new and cool and what's not is or will be using Kubernetes. But I'm fully aware that my vast majority of applications and processes and what's not are not running in Kubernetes, will not be running for Kubernetes, and in those cases, there is no need for anybody to create a new tool that will do life cycle of those applications, simply because the tools that handle those things already exist. There is Jenkins, TeamCity, I don't know, Bamboo, and all those tools. They are all the problem before Kubernetes is solved. I don't want to spend time solving those problems. I want to solve problems that are coming next. I don't know if that answered your question. If it didn't, follow-up question.